Okay, I believe we are live. Came in a little 2 minutes early just to make sure people have time to hit the refresh button before we begin. Won't get started just yet, but hopefully I'm coming through. All right, it's 4:30 my time, which is I guess 20:30 UTC. So we are at the start of office hours. Don't forget to hit refresh. Well, I guess if you can hear me, you hit refresh in your browser so the stream is kicking in. So welcome to World Quant Office Hours, Week 4, Office Hours 16. Kind of hard to believe that we've gone through 16 office hours. We are halfway through the course. A little crazy to think that, but I guess that's how time works, right? Time marches on for the better or for worse. Let's see who is joining us today for office hours. So I see Bismarck. Hello, Bismarck. I see Tom. Hello, Tom. Emmanuel. Hello, Emmanuel. Edward. Hello, Edward. Lyndon Smith. Hello. Naya is here. Hello, Naya. Shakiba is here. Hello, Shakiba. Welcome to office hours. Hope everyone is doing fine today as we march through our course. And on my agenda, I have the PW mini project PWQ4, which is a gargantuan question. We're going to break it down. We're going to analyze it. We're going to talk about strategies to solve it. We are ready to tackle that, so it's on the top of my agenda. However, as always, you are welcome to introduce additional topics for our agenda. I do keep tabs of past topics. And let me see. Someone did ask about Pickle, Python Pickle. So if we have time today, I can definitely talk about the Pickle package, the Python Pickle package. Try to say that several times over. Python Pickle package. Put it right there. All right. All right, so I see a couple of things people posting here in the chat. I see Crossing More is here. Hello, Crossing More. Naya is saying, my result for exercise most common item is a tuple. What should I do to get it as a list of tuples? So let me go ahead and pop that open and address that question. Mini projects PW. Let's go where we left off. Kernel, or restart and clear output, and cell and run all above. Yeah, is it okay to create a list and inside put the tuple? Yeah, you can do that. That's essentially what you want to do there. Nothing too complicated. You can just copy paste it and slap it in right there. This is for Q3, Q2, I believe. Q2. Right, items by, let's see, a max item. So you can do something like this. Just put brackets around the call of max. that's what you can do. So call this, let's say, max item. And that should be sufficient to get your answer ready for the grader. All right, anything else we want to throw up on the agenda or ask me right now? It looks like for some reason my webcam is a little bit on the side. Okay, let's see if that fixed it. Yeah, so nothing fancy, just you can put it inside brackets and have a list of a single tuple. I see Esther is here. Hello, Esther. De nada. Yeah. I'm always kind of curious to see what would be the Spanish word for tuple. Because you can say lista for list, but tuple, I'm not sure what the Spanish word for tuple. You can say tuple, but tuple sounds a bit pocho, right? I'm not sure what would be the proper. I guess I can go to Wikipedia and look up the article for tuple and see the Spanish translation. But I can do that offline. But if you know the word for Spanish word for tuple, do let me know. I am kind of curious. Okay, anything else to throw on the agenda before we take a crack at the PWQ4 mini project? Let me just run these things before from our previous office hours. Es tupla, una tupla. Ok, gracias, tupla, una tupla. You have a tupla, o you have a lista, and adentro de la lista una tupla. Una tupla de medida, creo que era una. ¿Qué medida? Medida, yeah. A linked one. Anyways, well, all right, I see Aki Beeman is here. Hello, I'm not familiar with that name, but welcome to Office Hours. Let's go ahead and start our discussion of Q4 and what we're looking for in Q4. All right, so in Q4, what we want to do is we want to find for each postal code the BNF that was prescribed the most. So for each postal code, we want to know which drug was prescribed the most. And not only will we want to find the drug that was prescribed the most, we want to know the ratio of its prescription for its postal code. In other words, if I were to sketch this out, if a given postal code, I'm going to call that ABC123, and the drug that was most prescribed in this postal code was Tylenol. And let's say 100 items of Tylenol were prescribed out of, 1,000 items. So for the postal code ABC123, the most common prescribed drug was Tylenol, with a total item of 100 compared to 1,000 item dispersals for that postal code. That means that we say A, B, C, 1, 2, 3, Tylenol in that ratio, which is 100 over 1,000, which comes out to 0.1. All right, someone is saying, what is the role of AWS in data science? I can talk about that or put that on the agenda. Okay, so that's what we want for each postal code, the most prescribed drug and its ratio for all the items for that postal code. So in this approach, in this calculation, is the first thing we need to do is we need to find the total number of items for each postal code and for each BNF name. So in other words, we'll take a postal code, we'll take a BNF name, and find the total. Then for the same postal code, but for a different BNF name, a different drug, we calculate the total. So what we want to do is we want to find the total for each BNF name and for each postal code. And every time you find yourself asking, I want to do X for every blank and blank, what that means is you want to group your data by those fields. I want to calculate the total for each postal code and BNF name. That means I need to group my data set by postcode and BNF name. Okay. And we know how to do that. We know we have the group by field function, which we can try out right here. Group by field. We give it the join data set and say, hey, we want to group by postcode and BNF name. Do that right there. I want to call this result grouped by BNF name and postcode. A bit of a verbose name, but it describes what it is. It's taken our data set and we grouped it by those two fields. So group by field, joined, postcode, and BNF name. And now what we can do is we can take that output here of that grouping and we can calculate the sum of all the items for all the key value pairs. Remember, this will return to us a dictionary that maps. Let's try it out. All right, let's go ahead and try this out. And we do group by field, and I won't print it out because it will kill my kernel. But I can just take, for example, maybe one case right here. And here are all the prescriptions that belong for this postal code and this drug name. And there they are. So we have tuples mapped to lists. The next thing we want to do is let's go and iterate through these key value pairs, having a collection of lists where the 0 index is a key and the 1 index is the total value of items. In other words, we can say for key value and grouped by items, grouped by BNF name and postal code dot items. This will iterate through those key value pairs. And we have create tuples where the 0 index is a key and the 1 index is a result of calling the sum values for that list and for the field items. And we will call this total items by BNF post. And now if I take a look at a slice of that, what this means is that this postal code and this drug total 5 times, right? This postal code, this drug prescribed a total of 41 times. So the sum of items, 41 items were prescribed for that postal code for that drug. So first thing we're going to go ahead and do, I'll make sure I am not frozen. For some reason I think I'm frozen. Let me refresh my page. All right, I'm not frozen. For some reason I thought I was frozen. Let me know if there are any questions right now. Let me take a look at the chat. Someone asking about AWS in data science. So I'm going to put that as a point here. AWS in data science. All right, let's see other questions I have. Someone is saying that they have issues with the PW Mini project the notebook has refused to open up recently. So one thing I think what can be happen here is that if in your notebook you printed out the entire data set, in other words, you did something like scripts and you ran it, it's going to display all the entries for that list. And the problem with that is that displaying that content takes up memory. And it's a very large list. And what happens is if you go into your notebook, you will realize that your notebook is a very large file size. Perhaps if you look at this here and your notebook is having trouble opening, your file size for the notebook is probably on the order of 50 megabytes, maybe 20 to 30, maybe 20 to 100 megabytes. So it's very intensive for the system, for the server to display the contents. So what I suggest you do is if you're having issues with your notebook and you realize the file size is anywhere from 20 to 100 megabytes, then what you should do is you should go here and do cell, all outputs clear. That's going to clear all the displayed outputs and hit save. And that's going to reduce the file size of your notebook. In fact, if you see right now, my notebook is running a bit sluggish. So what I'm going to do is I'm going to look for areas in my code where I printed out things that's taking up a lot of space, like right here. This is probably taking up a lot of space. It's making my notebook run slow. I'm going to click this, cell, current outputs, clear. Same thing here. Cell, current outputs, clear. And notice right now, my notebook is drastically reduced in file size. I'll hit save. But before, it was about 3 megabytes, and now it's about less than 200 megabytes. So if you're having that issue, it's going to happen. I know a couple people had issues. Don't print out the entire data set. And it's going to run slow, so go to that cell. You can either do cell, all outputs clear, or go to the individual cell that has the large printout and go current outputs clear. So do try that out, and do let me know if that resolves your issue or it still persists. Okay. Questions people have right now. What we've done, we've taken our data set, we grouped it by those two fields, the BNF name and the postal code, and then we calculated the total of items for all the prescriptions that share the same BNF name and postal code, which is what we displayed right here. Alright, so what is next is to make sure we pass the assert. So we'll take the length of total items by BNF post. Let's run that. So we pass the assert. Now let's go ahead and march on for this question. But if people have questions, do bring them up. Alright. So the next thing we're going to do is we're going to take our current result, our total items by BNF post, and we're going to flatten out that data structure. We're going to take what we've got and we're going to create a list of dictionaries where we have three keys. And the keys are post code, BNF name, and the total. So we're going to take our list of dictionaries, so our current result, which is, let me go ahead and look at that, which is a list of tuples, and we're going to create a list of dictionaries. That's going to map where key postal code, the BNF name, and the total. So let's go ahead and construct that right now. I'm going to go do this, define a function called construct dictionary. And what this does, it accepts a key, a value, and it returns a dictionary based upon this value. In other words, it's going to accept a tuple. So accept a tuple and return a dictionary mapping the values of that tuple to a given array of keys. So post code, key of 0, the BNF name, notice the BNF name is the 1 position, and total will be the value. And this is what we return. We call that function. Because now if we have this function, we can say for key val in total items by BNF post. We're going to iterate through these list of tuples. And then what we're going to go ahead and do next is we take the key val and we construct our dictionary, key and val. And we'll call this total items by BNF. So now let's go ahead and take a peek at this data structure, total items by BNF. And notice it's kind of like, it's pretty much what we had before, but we reformatted our answer to be a list of tuples, sorry, a list of dictionaries. We've taken that list of tuples and we formatted it to be a list of dictionaries. I'm going to pause right here and let me know if there are any questions. I know a lot is going on here. So do let me know if you have any questions, any follow-ups. Okay, I will march on. Now with our total items by BNF, that list of dictionaries, what we're going to do next is we're going to group by postcode because we want to find the total items by postcode. And the reason we want to do this is because we're able to figure out the total number of items for each postcode and BNF. And now we want to figure out is the total number of items for each postcode, and we need this to calculate that ratio. Remember, we want to report postcode, BNF, and that ratio. All right, so the next steps is I take my group by field, keep on reusing that function, pass in the total items by BNF, and we only want to group by postcode. Do that right there. And we'll call this grouped by postcode. Give it something descriptive, group by postcode. And now with that group by object, we are ready to calculate the total items for each postal code. So in other words, for key value in group by postcode items, so the key here would be the postcode, the value would be the array, the list of prescriptions for that postal code. And remember, since we're using the group by field function, it accepts the field as a tuple, so our keys are tuples. It only has one field, so we'll have to make sure we say key 0, and we'll call the sum values function. We pass the list, and we want to calculate total. We'll call this result total by items by post. I got a key error because, well, there is no key called TOTA semicolon. I have a typo. I run that there, and let's examine a slice of my result. So total by items by post. Take a look at the first 5, and now I have the total items for each post code, for each postal code. I'm going to copy and paste this right here. So as comparison, I also have the total number of items for each postal code BNF name. And let me check my assert. I get a name error because I called it total items by post and total by items. I called it something slightly different. And I probably should stick to what we have, total items by post. Just call it what we called it in the template. And I pass my assert. Okay. So let's take a survey of what we've done. We've calculated the total items by BNF, by postcode and BNF, and the total items by post. And now the next thing we got to do is let's find the BNF name and its total with the most total items for each postal code. So in other words, for each postal code, we want to see what is the BNF name that had the greatest amount of items. So this of course would mean, well, let me go ahead and throw it back at you guys. So what does this mean that I got to do? I want to figure out I want to find the BNF name and its total with the most items for each postal code. So what does that mean I need to do? I need to do some sort of grouping, but by what? Alright, I see someone posted here in the chat. I tried your suggestion on the PW issue after clearing this up and trying to save, and it shows an error, load failed, save disabled. Alright, so if you're having still further issues, let me know your username. Let me know your username. If you do let me know your username, I can go into your pod and I can see what's up and fix the issue. In fact, I would do that right after office hours, but please let me know your username so I can fix the issue. All right, well, you're getting me your username. What we need to do is we need to group by postal code. And I think we already have that data structure. Called group by postcode. Or I can check it out. I can give a postal code like this one right here. It's got a key error. It's not indexable. There it is, because they are tuples. Right, so this here are all the prescriptions for that postal code. So what I can do is I can iterate through all of these items, so the values of that dictionary, And what I want to do is I want to sort them by their total. And I want to return the greatest one. So if I say for val and group by postcode values, and then I call sorted, let me first do this just on one in particular so we can see the strategy for one and then we can implement the for loop. Sometimes it's a lot easier to just focus on one and expand it to more entries. So for example, group by postal code, I give that sample one I have here. And what I can do is I can call sorted on that data structure. However, I get a type error saying unsupported instance between dictionaries, because what I'm trying to do here is I'm trying to sort dictionaries. There really is no understanding how to sort dictionaries. So what we need to do is we need to provide it a key. We need to provide it a criteria to sort our dictionaries. And that criteria would be whoever has the highest total. But if we look at the questions in the instructions, what it says, let's see, some will have the same number of items prescribed for the maximum. In this case, we will take the alphabetically first BNF name. So in other words, we can call sorted, and then we can pass the key. Remember, here was a callable that said the criteria we use to evaluate the elements in our array, in our iterable. So I can say lambda x, and I can say total, and say reverse equals true. Now I'll take a slice, first 5, and sure enough, it looks like I've sorted the dictionaries by the total, right? This is 706, 451, 387, and so forth. So it looks like I am properly sorting them. However, I haven't done anything about if there's a tiebreaker to sort them by alphabetical order. All right, so I see your username, so I will write it out right now, and I will get to it after office hours. So another way to specify additional criteria in the sorting is we can make this function here return a tuple, because it will use the 0 index as the first criteria, but then the 1 index for the tiebreaker. So in other words, to sketch that out, if I have a tuple, let's say 45, and another tuple of 45, this is A, and this is B, what it's going to do is going to first look at the 0 index. And that's what it's going to use first, and then as a tiebreaker, it will move on to the next index. So what I can do here is I can say total and BNF name. And that's here is a second criteria. However, since we set reverse equals to true, what it's going to do, it's not going to do what we want it to do. For example, let's give it some test data. And let's say I have total is 45, and I have 45 and BNF name is A. And I have another one that says total is 45. BNF name is B. And another one that says total is 5, let's say 7. And its BNF name is, I don't know, let's say C. And just make sure I got, missing right there. And I'm good to go. So I got my test data. I can call sorted on test data and say key equals lambda x and return x total. And set reverse equals true. All right, so I think maybe this underscored what I was trying to say. Hold on. Yeah, I think this works out because under this here, notice how this one is first, and that's what I want. It's alphabetically first, so I want this one to be on the top. So now that I know how to work it out for one of them, I can replicate it using the for loop. So in other words, for val in group by postal code values, I can call sorted on val and say key equals lambda x total and reverse equals true. And since I want the top one, well, I'll just index 0. And I'm going to call this max item by post. And take a look at a slice of that. Max items by post. And I see postal code, the drug, and how many is the total number of items prescribed there. All right, any questions people have at the moment? Essentially, I've gone through this data set and I've returned what is the greatest, what is the item that has the greatest number of prescriptions for that postal code. So I'm not quite out of the woods just yet. So what I have here is I have the postal code, I have the BNF name, but that last piece of information is this ratio here. And for this ratio, it's equal to this numerator over the denominator. And the numerator is the total, is the number of items, the total number of items prescribed that had the greatest, sorry, let me back that up. The numerator would be the BNF name that had the most total prescriptions. The total will be at the top. And the numerator goes the total number of items for that postal code. And what we have here is this data here is the numerator. It is the total number of items for the drug that had the highest value for that postal code. So this right here is the numerator. And next, I got to bring in the denominator. So what I have to do is I have to find an easy way. And if I look, hold on, I have this data structure called total items by post. take a look at that. I think it is a tuple. All right. So here is the numerator. So this here is our denominator. Sorry. This here is our denominator. And what I have here is the numerator. So what that means is I can take this first one here, I look at the postcode, I take this data structure here, and I check the value for that given postal code. In other words, I can take this postal code, then I go through this data structure and look for what is the value for that given postal code. However, how do we easily look up this value for a given postal code? We have a list of tuples, and how do we go and figure out what is the one index of the tuple when the zero index is a given value? That's our problem right now. It's not so clear how we can do that. We could do something like this. We could say for postcode and total items by post, and I can say if postcode is equal to, let's say, one of interest, one of interest, something like that, then we can say denominator, denom, is equal to total. I can do something like this. I can say postcode target, the one we're looking for, I'm iterating through all the tuples of this list. I'm checking with a postcode if it's equal to the target. There should be double equal sign since it's a comparison. And if it's true, and then I got my denom, and I can say break. I can do that, and let's check it out. My denom, 43,163. Yeah, I got that answer right there. So I could do something like this. In fact, I can encapsulate it into a function called find denom that accepts postcode target and accepts total items by post. And I can use it whenever I have to have it for my process. I can do that. However, this approach here isn't very efficient. This here will require me to iterate through this list of tuples every time I have to find what is the denominator for a given postal code. And I see that. I have to iterate through all the elements of the tuple. Yes, I might be able to break early, end early, but on average, this is an order n time complexity. Because if I have 100 items and if I were to double it, the average time would double. It's an order n process. On average, I would find it halfway through. So notice it's going to scale by the size of my data structure, a linear scaling. If it took 10 seconds to go through 1,000 and I were to double it to 2,000, it would take on average 20 seconds. So there's got to be a better data structure I can use. I want to use a data structure where the lookup time is order 1. The time to look up an item in a given data structure, I want it to be an order 1 process where I don't have to iterate it through. An order 1 process is one in which the time it takes to run it is independent of the size of the data structure. In other words, if I have 1,000 entries, it would take just the amount of time if I had 2,000 entries. And the data structure I'm going to use here is a dictionary, because a dictionary has an order 1 lookup time. In other words, if you have a key, the time it takes up to look up the value for that key is independent of the size of your dictionary. I don't have to iterate through to find the value. The way that the dictionary is implemented underneath the hood makes it such that it's independent of the size of the array. As long as I have the key, the time to look up the value for the key is independent of the size of the array. So while I could do something like this, what I really need to do is I need to take this data structure and convert it into a dictionary. And I can do so very easily by calling the by calling the dict constructor. This here is a list of tuples, and if I give it to the dict constructor, total items by post, call this total by items by post dictionary. The total items by post, and I give it, let's say, this particular one. Got a type error, and let's see what can be going wrong there. It says list integers must be slices. So this here is a list because it's post items. It's total. There you go. Items by dict. There we go. And I realize I named my variable names kind of complicated. I should really call this total items by post dict. I think that might simplify things. And this here is an order 1 lookup time. All right, we can try time it. And try the old way. Call it time it there. This took about 50 nanoseconds. This took about 300 nanoseconds. So I'm saying, is that a standard function? What is a standard? What are you referring to? What if it's a standard function? Are you referring if this is a standard function, the dict constructor? Yes, it's a built-in structure. It's a built-in function in Python. And this here we can use using dict to create a dictionary from a list of tuples. And the way it works, it takes the tuples. The 0 index is the key. The 1 index is the value for that given key. So now what this means here is we can go ahead and we can iterate through all the max items by post. And then what we're going to do is we're going to create a tuple where we have the post code, the BNF name, and what follows next is the total, our numerator divided by our denominator. And our denominator we're going to look up by the total items by post dictionary, post code. So this here retrieves the postal code, and we proceed to index this dictionary with that postal code, and that calculates the ratio. And we'll call this here items by region all. If I look at this, items by region all, and I take a slice, here is the postal code, the BNF name, and the calculated ratio. And then finally, what we want to do is we want to sort it and return the first 100. So I can say items by region, sorted, items by region all, and take the first 100. And I can take a slice. And here all, take that, and I'm ready to submit to the grader. In fact, the first one is the one that's already there, and I think we'll get the correct answer. So let me know if there's any follow-ups here. I know this is a long question, but we went through a lot of loops, hoops, and jumps and whatnot to arrive at the final answer. But we finally have the postal code, the BNF name, and the ratio. Okay, do let me know if there's any follow-ups, but what I plan to do next is tackle one of these things on the agenda, and I'll reserve pickle maybe for Monday, so I want to get a little more time. We got 10 minutes left. Let me talk about AWS. Someone did ask about AWS in data science. So what AWS stands for Amazon Web Services. Basically, the Amazon branch that provides a lot of web services, hence the name. Some of those web services include servers that I can easily rent. It can also include data storage solutions. So in fact, we use AWS to run this course. We use AWS for various ways in this course. For example, we rent out a set of servers to run your pods. Your Jupyter Hub is running on AWS server, and the great thing about it is because we don't have to maintain those servers. Those servers that we don't maintain, we don't house ourselves. We basically rent them from AWS. And it's very easy to do this because we don't care about where those servers are located. All we got to tell AWS, all we got to tell Amazon is, hey, I need X amount of servers. This is the amount of disk space and the amount of RAM we want for each server. Go ahead and give us those servers. So it's very easy for us to host services on AWS. And in fact, we host your Jupyter Hub on AWS. That is one way we're using AWS for this course and in data science in general, because you can imagine if I have a very large data set or multiple data sets that I cannot process on a single machine. This is in the field of distributed computing, where I take that data set and I break it and I partition this data set across a cluster, across a set of computers. And each circle here is a computer. I distribute that data set to all these nodes in this cluster, and then I can run a distributed computing framework. I can run something like Spark, which allows me to analyze data using a distributed computing framework. Distribute out the data set across these nodes, and they're all connected to each other because they can send information back and forth to each other. Have the calculation perform on these nodes, and then send back the results to me, to some sort of main node, the driver node. If I want to do this, I can easily rent a cluster using AWS. The other situation in which we use AWS or can be used for data science is Amazon Web Service provides what's called S3. It's a service where we can store data for us to easily retrieve. In fact, if you look at this code here, what it's doing, it's downloading this data set that we are hosting on what is called S3. S3 stands for Simple Storage Service. Basically, it's a product that AWS provides that makes it very easy for us to host information, host files, whatever. In fact, one of the things we do is we host the notebooks on S3, on the simple storage solution. It's in what's called an S3 bucket, to use that phrase. And what is happening is that every time you go to your pod and you hit Start My Server, what is happening is this is calling on AWS to say, hey, provision a cluster, in our cluster that we're renting out, provision them a node that they can run. And then what we do is we got to provide the notebooks to run the node, the notebooks the node needs. And those notebooks are stored in S3. So then in this initializing script, when the server is starting up, it gets from S3 the notebooks and it sets it up in our environment. So yes, Amazon Web Service is very common, used in data science. It's just one provider, by the way. I'm not trying to endorse AWS. I'm not trying to endorse Amazon. We in fact use it. That may not be the case. You can perhaps use a different provider, but it's basically going to provide you cloud services. Other competitors are Google. Google provides similar functionality. There is Heroku, also doing something similar, which we'll examine later on throughout this course. And there's Azure, which is by Microsoft. So very much AWS is in common data science for the fact of maybe analyzing a large data set, be able to rent and scale your process by renting servers, or maybe using S3 to host data sets that can be easily downloaded for your application, the storage solution, and then download it for your application. Okay, I can scratch that from the list. Okay, we got a couple more minutes left, so the floor is open. So any questions people have? Someone is saying, is this the only practical way to host ML applications? The answer is no. One common service, you can use Google Application Engine. You can use Heroku. In fact, once we've gone through all the mini projects, I do plan to work on a web application and host it on Heroku. In fact, we can host machine learning applications on a service like Heroku. The reason why I like Heroku is it is free. And not only is it free, is when you sign up, you don't have to put a credit card down. Some free services are free, but you got to put a credit card. They might charge you. Ideally, they don't. But I like Heroku because you can sign up for a free account, get things deployed without even putting down a credit card. So there's lots of people have, it's very common these days, Amazon, Microsoft, Google, they all have their cloud solutions. Okay, any questions people have? I think there was a lot to unpack today, so I might want to take the time and reflect on what we did. That last question is a tough one. Does anyone do it in-house? Not so common. And the reason why is because people don't want to maintain their own servers. People don't want to have to maintain their own servers and have to buy more servers if they have to scale up their process. Because not only do I have to maintain my servers, I've got to be ready to scale them up if I need more. The nice thing about these web services is that it's very easy for me to rent a amount of servers for maybe I need it for a day. Maybe I need a 100 node cluster to do some analysis, and it's only going to run for maybe a couple of days, and I don't want to have to deal with it anymore. That prevented me from running by my own servers, and maybe I only use it for a short period of time and they just sit there. So that is why people don't do it in-house. Not saying there's not unheard of, but if you have to do, the reason why people might do it in-house is because it's maybe small enough, maybe they have the expertise, or maybe they have to host sensitive data that they don't want to share or provide on some sort of third party. So Emmanuel was saying, any update about unable to connect to kernel? And I looked at your pod yesterday and I was able to get in no problem. I was able to get into your pod with no problem. So all right, so it looks like Emmanuel has got their problem fixed. All right, so Emmanuel Ragaza, the kernel dies. What happens for the kernel to die? Do let me know, because I got into your pod yesterday and I didn't see anything wrong. But do let me know if there's something you do specifically that causes a kernel to die. But I can take a look at your pod once again this evening. I was able to get in on it yesterday without a problem, but I can take another look. It should be working though. All right, with that said, guys, take care. That is the end of office hours for this week. Take care and see you next week.